Hey, John Bella here. For the last couple of months, I've been working on a ground up rewrite of my Learn State Machines course, and I thought I'd take some time to share an introduction, a basic introduction to XState and state machines. I'm not rewriting the course because it's bad or anything, but since it was released in August of 2018, React has come out with hooks. XState has released version 4. There's been a ton of updates in everything that the course uses, and so I've been kind of deep in the trenches of really just pulling all of that back and really starting over from scratch, keeping kind of the theme of the course, but it's the same application, but a completely rebuilt application. And so as I've been in the midst of that, I went back and reviewed an old post on a complete introduction to state machines and JavaScript, which was also released shortly before hooks and XState 4 were announced. And I started looking down at some of the code examples in here, and I felt like they were a little bit dated. And so today I wanted to take a little bit of time and actually go back and rewrite that using XState 4 and React hooks. So to start off, a finite state machine is any abstract machine that can be in exactly one of a finite number of states at a given time, and the transitions between those states happen in a deterministic way. So, for example, in this payment form that we'll be building, we have 4 states. We have an idle state, which is what happens when the user loads the payment page. We have a loading state, which happens after the user hits submit. And then we have either a success or error state. And what we'll do is we'll actually sit down and we'll build us a little payment form. I look forward to diving in. See you on the other side of the intro. State machines are a mathematical model of computation that has been around for decades. They're incredibly popular in fields where reliability is incredibly important. So, for example, in avionics, in self-driving cars, in manufacturing. In fact, you can actually think of a lot of code examples too in things you may have used that are also state machines. The example I give here is promises. So promises are a state machine. So when we jump over to the documentation for promises, it literally defines the state machine for promises. You can think of those as a promise as being in one of 3 states. When you call the promise, it is in the pending state, and then it can either be fulfilled or rejected. And regardless, it will transition from pending to fulfilled or pending to rejected, but never fulfilled to rejected. So you can think of state machines as providing kind of a guard in the way things happen. So the first thing that we'll look at is we'll start actually building this payment form. So I have a payment form here that is just some markup. There's nothing attached to this this markup. There's no, it doesn't really do anything. So what we want to do is first define the state chart or state machine for this application, for this component. So we'll start with state machine. And then what we need to do is pass an object to machine, which we will import from XState. Now, the first thing we want to do is define our initial state. So when our state chart or when our component loads and our state chart is instantiated, it will start in the idle state. Then we can define a set of states off of there. Oh my God, I can't type. So the first one is going to be idle. And then whenever we see the submit event, we want to transition into the loading state. Then when we're in the loading state, when we see a payment received, we can go to a success state. When we see payment failed, we can go to an error state. Then we can define our error state here. All of this is just a regular old object, JavaScript object that we can define our states and the transitions between those states on. So when we're in an error state, we want to provide the ability for users to then submit the form again after we've displayed an error message. And then when they do, we can send them back to the loading state. And then finally, we have a success state, which will be our final state. These are the 4 states and the three different events that we want to act upon. The great thing about state machines is that they allow you to visualize the logic of your component, and with the help of state charts, also the logic of your entire application. So XState has a visualizer that we can actually go and take our machine and just drop it into. And when we do, we can see our machine starts in the idle state. And what we can do is we can pass an action to that. The first thing is I want to show you is that when you're in the idle state, if you see an event that has nothing to do with your machine. So for example, if we send an event exit, nothing happens because our machine is programmed to only respond to a submit event. So when we send that event, you can see that we transition into the loading state. And again, if we were to submit again, then nothing happens. So the great thing about this is, especially in like a payment form, you don't want people to be able to just hammer on the submit button and potentially submit 4 or 5 or 6 payments, because that is a pain to deal with. So if you prevent them from transitioning into that submit state again and from calling your payment method again or your payment function, then you can guard yourself against those bugs. So the next thing we can do is just say that we received a payment, and then we go directly into the success state. So there's nowhere to go from here. If we send that event again, nothing happens. If we send submit. So we know now that our machine as it stands is going to meet the demands of our application. The next thing we need to do is to actually set this state machine up to do things for us. And the first one is going to be when a user hits submit from the idle state, we want to add a guard, because we don't want to submit a payment request with no data in it. So what we can do is add a guard here, and we can look at the guard docs real quick. So guards are conditions that need to be met, and they return a Boolean, whether true or false, and tells you whether the machine should go into that state or not. So what we can do is we can actually define an array here, an array of objects. And so the first object is going to be the target of loading state. So the condition here is that we want all of the fields to be filled out. So we can say event.data.name is not empty, and event.data.card is not empty. So I'm being a little bit verbose here just for clarity's sake. You can absolutely do things like filters and whatever to loop over a number of different fields and run operations against them. But since we only have 2 fields here, I figured I'd make it easy and very clear to show you how this happens. The next thing, the second object on this array, what we're going to do is we're actually just going to say target error. So what this is going to do is when we submit, it's going to go and see if it can transition into this state. If this condition is met, then we'll go into the loading state. If this condition returns false or it fails, then we'll go into the error state, which is the next key on this array. So we can give that a save, and we'll wire this all up in just a few minutes so that we can actually start testing. But the next thing is, or actually, let's go ahead and do that. So the first thing we want to do is const machine and then send. So with React hooks, whenever you return from a hook, typically you're going to have the first value in the array that you're going to destructure is going to be the current state. And then the second value is going to be an updater function that you can call. And in this case, we're calling it send. But right now we don't have a machine hook. And I typically, when I need a machine hook, is I go to the XState documentation and then hooks. And then this right here is basically the standard hook that is recommended by the XState team. And we'll just go ahead and copy paste that. Go ahead and grab the imports as well. Drop that over here in our code. And then we'll combine. Oh, we can just go ahead and grab all these. We'll go ahead and combine these imports and make it easy. I'm actually not sure if you can do these a little bit easier. For example, if I were to just save and it were to organize my imports, I don't know if that would have worked. But so now we have a use machine hook. And to walk through here line by line, again, what I just mentioned is when we use state with React hooks, typically what you're going to get is it's going to return a tuple, and the first value in this array that you can destructure is the current state, and then an updater function is going to come second. So then we have this variable here called service, and we use memo so that we can memoize the value and memoize this interpreter here. And what we'll do is you can see the first parameter on useMemo is a function in which we put our interpreter, and then the second one is an empty array, and that's the key here, because useMemo works like some other hooks where, for example, useEffect, where you can pass an array. So if you don't pass this second parameter, it's going to recalculate every time React updates. And if you pass this here is basically just going to be the values that you observe and act upon by updating. So for example, if we were to say we wanted to just act upon test, anytime test changes, our memo function will recalculate. Otherwise, it won't. So when we pass an empty array, we're telling React that we have no dependencies and that we do not want to recalculate our memoized value anymore. And then we do the same thing with useEffect. So we only run these essentially when the component is mounted, and then we only run this when it's unmounted. So here we have our interpreter. So if we want to just highly recommend reading the docs on this, but essentially the interpreter is going to take our machine, it's going to interpret it. So it's going to look and see what what actions it can execute, anything that goes along with whatever we define on there. You can write custom interpreters. So if you have special logic that you want to just bake into the interpretation of your machine, you're absolutely welcome to do that. But I just typically reach for the core XState interpreter. I've never really run into any issues with it. And then again, we just return out the current state and the service, the method to update our interpreter service. So we can say use machine, and then we just want to pass state machine. So that's going to be the default state for use machine. And then what we can actually do is console.log machine.initial state. And then we'll just make sure this is working. Undefined. Okay. So now we have our machine. So machine.value, not initial state. Sorry. So now we have our initial state. So the next thing we can do is, since we have form fields typically, so you can use context in machines to store data. So essentially use it for state management. And I like to do that, but I kind of delineate things where if it's data that is just user input on a form that we're going to send basically to the state machine, I don't update the machine on keystrokes. I kind of separate those things out. You absolutely can pass those through, and we'll look in just a few minutes at how to use context. But what I typically would do is have a second use state here where we'll say form, update form, and then I pass an object, name is empty, and card is empty. So we can go ahead and attach those to these form fields. So the first thing we want to do is go ahead and value is going to be a form.name. Oh, sorry, this is the card one. So form.card. Value here is going to be form.name. And then we need to be able to update these values, and we can do onChange. Pass the event in, and then so what we're doing here is we're using the spread operator to take whatever the value of form is and dump it into this object here. And then the reason name is last is because we'll overwrite the name value with the current value of this event. So we'll do that again here. Sorry, this is going to be name. I keep getting them mixed up, and I have no idea why. So this should be card. Give that a save. And then we'll just console log form so that we can actually see as we input that the state updates. So that's a positive. So the next thing we can do is wire it up so that when we submit the form, we send that to the machine. So on submit, what we'll do is prevent default. So since this is a form that typically when you would submit in the browser itself would reload, we want to prevent that from happening so that we can actually take over and tell the browser what we want it to do. So now what we'll do is we'll send the type of submit, and then we'll send our data in through there. And now we can give that a save and see what happens. So we were able to do that. It didn't refresh. It means that all of our stuff is happening as it should. So let's connect all of this with our machine. So this happened. Actually, what we can do, console log machine dot value. And we can see as we submit, we're still in the idle state. Now we go into the loading state. So that worked. Our guard was it was checked. Now if, for example, if we were to refresh, error state. So our state machine is working. So the next thing we can do is in our error state, we actually just want to add the same guard. But the difference is that we don't necessarily have to transition back into any other state. So what we can do is go ahead and just treat that as an object and say target, loading, and then condition. Same thing. We can just go ahead and copy this condition up here. Save it, go ahead and let Prettier format it. And again, what we can do here is refresh, submit now. Now it goes back into loading. So our guards are working. That's how we do guards. Next, whenever we enter the loading state, we actually need our state machine to be able to do something. So for that, what we can do is we can invoke a service. In the docs, again, it talks about invoking services. So you can invoke promises, which will take the onDone transition on resolve or the onError transition on reject. So that's exactly what we need to do. So on this, what we actually want to do is we don't need on anymore. We want to invoke a service. We'll call this due payment. And then the source of this is where we'll put our actual promise. And we'll say context, event. We're not actually going to pass anything in, so we can just give this an empty parameter. And then we'll say fake payment here, and then onDone, target success, and then let's see, and then on error, target error. We need fake payment to do something. So we can actually go ahead and write a function called fake payment, which will return a promise. And then inside there, what we can do is set a timeout and then resolve after 2.5 seconds. Give that a save. And then so we're still logging the value. We'll save that and then see what happens. So we're now in the error state. Loading, success. So whenever we entered the loading state, we called this method, which returned success. What happens if we reject that promise? So again, we'll go into the error state and submit, loading, error. So this is working. Now, the final thing to do will be to add some error messaging here. So for that, we can use assign. So assign is part of context or extended state. So while finite states are well defined in finite state machines and state charts, sorry, I'm reading this to you. Basically what it means is when there's quantitative data, like just the type of data you would typically see in state in React applications, users, user IDs, posts, things like that, those would fall under extended state, and we can use context for that. So what we'll do is on the service here, on done, we'll do actions. So actions are in the documentation as well, worth a read if you're so inclined. And what we'll do is we'll assign, and then we'll say message. This here also takes context and the event, and then we'll just assign the event data. And then we need to, okay, so it automatically imported, sweet. And then actually we want to do the same exact thing on error. And then we need to define a context here, and we'll just say message is an empty string. And then to output it, if our machine matches the state of error, we'll output a div called alert. And then inside there, we'll go ahead and grab our message. If it exists, we'll output it. And then if not, we'll just say, oh no error message. And then lastly, we need to just say null. So what we'll do here is if we have a message in context, we'll display it. If not, we'll display this error message here. So if we submit this form and we reject the promise up here in fake payment, if I can find it, there it is, we'll reject that, and then we'll say with the message no. So now we're able to pass messages from a promise that we call. So this is a helpful place. So if, for example, if you're logging a user in, you can return that user's data, set it in state directly within your state chart, and then move on with your application. So that is how to use guards and actions and context and all the basics that you really need to actually build a functioning, really, really strong application. So that's all there is to it. If this piqued your interest, like I said, I'm deep in the middle of rewriting my Learn State Machines course. I'm hoping to have it out in the next month or so. If you want to check it out over at learnstatemachines.com, I would love for you to check it out. If this video was helpful for you, please mash that like button down below. See you in the next one.